A very good afternoon to all the participants present over here. From the topic, you can see that today we are observing. So today we are actually observing National Pollution Control Day, and observing this particular day, that is National Pollution Control Day. So today we have our lecturer, our guest speaker, Professor Niranjan Kumar from Chaibasa Engineering College Civil Department, and he is also one of the member of our Institutional Innovation Council. So I'm going to short intro of Niranjan Kumar sir. He is currently working as an assistant professor in civil engineering department, and he have completed his graduation in civil engineering from Jadavpur University, Kolkata, and he have also awarded Master of Engineering in Water Resources Engineer from in Water Resources Engineering Department from Jadavpur University, Kolkata. And his subject of interest is soil mechanics, environmental engineering. So students, we are welcome. All the students, I am on behalf of IIC Cell, welcoming all the students as well as our guest lecturer Niranjan sir. So Niranjan sir, over to you. So you can share your screen. Sir, you are muted, so if you unmute.
Okay, sir. Thank you, sir. For my brief introduction, I am Niranjan Kumar, Assistant Professor of Chaibasa Engineering College and member of IIC Cell. Today, I am here to speak on the topic Observation of National Pollution Control Day. National Pollution Control Day. National Pollution Control Day, it is observed on 2 December as National Pollution Control Day every year. The day is observed in the memory of those who have lost their lives in the Bhopal gas tragedy in the night of December 2nd and 3rd, 1984. Many people the methyl isocyanate, also known as MIC. The Bhopal gas tragedy is considered one of the biggest industrial pollution disasters. Environmental pollution directly and indirectly affects the quality of life more than can imagine. All this is mainly caused by human activities which harm the environment in more than one way. Nowadays, pollution prevention is a major global concern because everyone on the earth is entitled to clean. The pollution level is so high that 9 out of 10 people globally do not have access to safe air. Notably, the pollutants present in the air are so tiny that they can pass through the mucous membrane and other protective barriers to the damage the lungs, heart, and brain. What is pollution? Pollution is an undesirable change in the physical, chemical, or biological characteristics of air, water, and soil that may harmful affect the life or create potential health hazard of any living organism. Pollution is direct or indirect change in any components of biosphere. Do you know what is biosphere? Biosphere is the zone in which atmosphere, hydrosphere and lithosphere meet, and it is capable of supporting the life. Biosphere that harmful to the living components and in particular undesirable for man, affecting adversely and industrial progress, cultural and natural assist or general environment of living society. Types of pollution. There are 5 types of pollution. First is water pollution, second is air pollution, third is soil pollution, fourth is radioactive pollution, and fifth is noise pollution. But in civil engineering, only 3 pollutions are important: water pollution, air pollution, and noise pollution. Water pollution. Water pollution, it may be defined as one or more substances have built up in water so such an extent that they cause problem for animals or people. Oceans, lakes, rivers, and other inland water can naturally clean up in certain amount of pollution by dispersing it harmlessly. There are cause of What are the cause of water pollution? There are certain causes of water pollution. First is sewage and wastewater. If we discharge sewage in a river or any water body like pond or sea, then it may cause water pollution. It will depend upon the discharge of river, discharge of sewage, and BOD of river and BOD of sewage. Do you know what is BOD? BOD is the amount of oxygen required to degrade the organic matter present in the water by the microorganism. The water pollution may cause due to sewage and wastewater, industrial water and water pollution. Sewage is also produced from the industry. Oil spills at the water surface. Actually, oil floats on the surface of water, due to which it prevents the entry of oxygen from the atmosphere to the water. Marine dumping. It also causes water pollution. Underground storage leakage. Due to the leakage of supernatant liquid, it also causes water pollution to the groundwater. Strategies to bring water pollution under control. There are 2 strategies to bring the water pollution under control. First is reduce or remove the sources. Either we have to remove the sources or reduce the number of sources, due to which the polluted water or wastewater coming from the industry or domestic waste will be reduced, or treat the water to remove the pollutants, convert them into harmless form. Now, how to treat water? Suppose from raw water, this is a raw water. We have to treat this water. How to treat? First of all, water pass through the screening. This is a screen. After that, water is passed through the aeration. After that, coagulation. After that, flocculation. After that, sedimentation. Filtration. Disinfection. And this disinfected water is supplied through the distributed system to the household. Now we'll discuss one by one each process. First one is screening. Generally, skins are used to remove the large floating material like wood, or it may be plastic bottle, those floating material which are on the surface of water are removed through the screening. Generally, two types of screening are used. First one is fine skin, second one is coarse skin. In fine skin, wire mesh type rod is used. Wire mesh like this. In which a square opening is there. The center to center distance between the rod is less than 20 centimeter. This distance will be less than 20 centimeter. Sorry, 20 millimeter. This type of skin is called wire mesh or fine skin. Second one is coarse skin. In coarse skin, the rods are like this. The distance between center to center between the rod is 20 to 100 millimeter. This distance will be 20 to 100 millimeter. The diameter of this rod will be from 10 millimeter to 25 millimeter. Coarse skins are used commercially because it can be cleaned mechanically. Skins are generally inclined at an angle 45 to 60 degree with the horizontal. Side view will be look like this. This is skin. This is river bed. Skins are inclined at an angle 45 to 60 degree. This angle will be 45 degree to 60 degree with the horizontal in the direction of flow. Suppose the direction of flow is like this. The velocity through the skin is suppose v and velocity upstream of the skin is u. Then the loss through the skin will be equal to, the head loss through the skin is equal to 0.0729 v square minus u square. Here which one velocity will be more, v or u? In this case, v will be more. Why? We know that discharge equal to area into velocity. If skins are present, in that case, the cross section, effective cross section area will be reduced. Suppose these are the rods, that is coarse skin. Suppose this is the cross section area of rectangular channel. Due to the thickness of rod, the effective cross section area, suppose this is the width of the rectangular channel and this is the height of rectangular channel. Height is h. In that case, if the rod is present, in that case, the the effective cross section area or effective width of the channel will be reduced, that is B will be reduced. So the cross section area will be equal to, suppose the effective width, that is B minus the thickness of one rod into number of rod. In this case, number of rod is 3. Suppose the number of rod is n, the effective width, that is B dash, will be equal to B minus n into T. N is the number of rod of coarse skin. So the effective width, that is B dash, will be reduced, due to which the cross section area will be reduced, and cross section area will be reduced, but the discharge will be constant. So the velocity will be increased. Cross section area decrease, velocity will be increased, discharge will be constant. So the V will be more than U. Here V will be more than U. So the head loss will be always positive. Aeration. Aeration is the process of dissolving oxygen into the water. Why we are doing aeration? There are certain objectives of aeration. First is removing the undesirable gases present in the water. What are the undesirable gases? Like NH3, H2S, CO2, etc. Second is increasing the dissolved oxygen content. Increasing the dissolved oxygen content. If in any water dissolved oxygen content is more, it means that this water is good, or we can say that in that water the BOD or the organic matter present will be less and it will be good. So after aeration, the dissolved oxygen content will be more and water will be good. Third one is removing the minerals present in water like manganese, iron, etc. Sedimentation. Sedimentation is a natural process in which suspended particles settled in the sedimentation tank by the action of gravity. In figure 1, certain particles, suspended particles, are present in the water tank, but after some time, in figure 2, the suspended particles are there but in less concentration, or we can say that after very much time the suspended particles will be not present. So due to the action of gravity, the suspended particles settle with time. The settling velocity of particle is Vs equal to G by 18 G minus 1 d square divided by nu, or d square divided by mu into rho. This formula is derived according to the Stokes law. Do you know what is Stokes law?
No, sir.
Okay, I will discuss later. Types of sedimentation. There are two types of sedimentation. First is plain sedimentation. In plain sedimentation, there is no any coagulant added in the water. Means the normal water which are present in the river or pond will be taken and the particles settle due to the action of gravity only. Second one is coagulation added sedimentation. In this case, the coagulant added in the water. Coagulant makes flock, due to which the size of particle increases and it will settle easily. Stokes law. What is Stokes law? Stokes law says that if a spherical particle falls through infinitely large medium of fluid, then after some time it achieves a constant velocity. This velocity is known as terminal velocity or settling velocity. Suppose this is the surface of water. If we put a spherical particle on the surface of water, in that case, what will be the velocity of this particle in that condition? We have just put a spherical particle on the surface of water. What will be the velocity of this particle? In this case, velocity of particle will be 0. It is an instant at which the spherical particle is put on the surface of water. So the velocity, initial velocity will be 0. In this case, the force acting on the particle is gravitational force only, that is mg. After some time, if this particle is immersed in water, in this case, velocity will be very small. So the only two forces acting on the object, on the particle. One is gravitational force and other is buoyancy force. If this particle goes down after some time, then the three forces acting on this particle, one is gravitational force, other is buoyancy force which is acting in the upward direction, and other is drag force which is acting. Drag force is acting in the of the moving object. This object is moving in downward direction with velocity, suppose v. Then the drag force acting on this object will be upward direction. Do you know what is drag force? What is the formula of drag force? Drag force is equal to half CD rho W APV square. Initially, the velocity, suppose this is case 1. This is case 1, this is case 2, and this is case 3. In case 2, the velocity is very less. In case 1, velocity is 0. In case 2, velocity is very less. If velocity is very less, in that case, drag force will be also very less. So the drag force in condition 2 is negligible. But in case 3, the velocity is increased. So the drag force acting on the object will be significant. After some time, so the net force acting on the object will be in downward direction. Where the drag force acting in upward direction, buoyancy force is acting also in the upward direction, and gravitational force is acting in downward direction. But after some time, the net force acting on the object will be 0. In that condition, the velocity of this object will be called settling velocity, or it is called terminal velocity. In this case, the total force acting on the object will be 0. That is, downward force is equal to upward force. Downward force is gravitational force, that is m into g. M is the mass of the particle, g is the acceleration due to gravity, and upward force is buoyancy force and drag force. What is buoyancy force?
Force applied by water.
Weight of water displaced by the particle is called buoyancy force. Weight of water displaced by the particle so drag force will be equal to weight of particle. How to calculate the weight of particle? Weight of water, this is equal to the volume of water displaced by the particle. volume of water displaced into unit weight of water. This is called the drag force. What will be the volume of water displaced by the particle? This will be equal to the volume of the particle. The volume displaced by the particle will be equal to the volume of particle. Volume of water displaced by the particle will be equal to the volume of particle into unit weight of water. Now, how to calculate the volume of particle? Suppose diameter of this particle is d. Then the volume of particle will be equal to, what will be the volume of particle? Four by 3 pi r cube. Four by 3 pi into r is equal to d divided by 2 whole cube. This is equal to pi by 6 d cube. After putting all the values here, drag coefficient, this will be equal to 24 divided by re. After putting all the values in the equation, buoyancy force plus drag force, this is equal to mg. We'll get a relation. Settling velocity vs is equal to g by 18 g minus 1 d square divided by nu. Here g is the acceleration due to gravity. Capital G is the specific gravity of particle. D is the diameter of particle and nu is kinematic viscosity. What is the unit of kinematic viscosity? SI unit of kinematic viscosity.
Meter square per second.
Meter square per second. What is the CGS unit of kinematic viscosity?
Stock.
No. CGS unit is centimeter square per second. What is the SI unit of dynamic viscosity? That is mu. This is Newton second per meter square or kg per meter second. What is the CGS unit of dynamic viscosity?
Stock, sir.
Stock. Limitations of Stokes law. There are certain assumptions for the analysis of Stokes law. First is particles should be spherical in nature. Second one is medium should be infinite. The medium here we have used is water. Discrete settlement. Do you know what is discrete settlement? Discrete settlement means suppose different particles are present in the water. During the settlement, particles do not make a flock or do not combine with each other. This is called discrete particle settling. Discrete particle settling. If different particles combine with each other like this, in that case, Stokes law will be not valid. Laminar flow. Laminar flow means Reynolds number should be less than equal to 1. Do you know what is Reynolds number? It is the ratio of two forces. What are those forces? Reynolds number is the ratio of two forces, inertial force and viscous force. What is the formula of Reynolds number? Is equal to rho Vd by mu or Vd divided by nu. Types of sedimentation tank. Generally, there are two types of sedimentation tank used for the settlement of suspended particle. First one is rectangular tank, second one is circular tank. Rectangular tank. Rectangular tank is also known as horizontal flow type tank because water enters horizontally and leaves the system or settling zone horizontally. Suppose this is the height of this rectangular tank is h. Length of this rectangular tank is L. This is the side view of rectangular tank. What will the plan view? Plan will be look like this. This is the width of rectangular tank, that is B, and this is the length of rectangular tank or horizontal flow type tank. There are certain assumptions to analyze the rectangular tank. First one is, as soon as water enters the settling zone, all the particles or suspended particles present in the water uniformly distributed at the inlet cross section. This is the side view, but in front view it will be look like this. All the particles are present at equal distance from each other. This is the first assumption. Second assumption is, those particles which settle, which touches the bed, is assumed as settled. Suppose at the inlet cross section a particle is present at this position, and after some time it touches the bed. Then we'll assume that this particle will settle. And third assumption is, all the particles which are entered in the settling zone settle with velocity Vs, that is with settling velocity. So there are three assumptions to analyze the rectangular tank. Surface overflow rate. It is defined as the settling velocity of the particle which enter at the top of the settling zone and just settle at the end of settling zone. Suppose at the top of the particle, at the top of the settling zone, a particle is entered. Suppose the diameter of this particle is d, At the end of this settling zone, this particle just settle. This is settling zone. In that case, the settling velocity of this particle is known as surface overflow rate. That is, it is denoted by V naught. So mathematically, it can be written as V naught is equal to discharge passing through the rectangular tank divided by surface area of the rectangular tank. Efficiency of those particles whose diameter is greater than d or less than equal to d is calculated by efficiency, and eta is equal to Vs divided by V naught. Or percentage efficiency can be written as Vs divided by V naught into 100. Circular tank. It is also known as vertical flow type tank because in this case water is entered vertically at the center and moves radially outward. Wear or flow rate is defined as discharge passing through the circular tank, that is Q divided by the perimeter. In this case, the plan view of this tank will be circular in nature, like this. Suppose diameter of this circular tank is D. Then the perimeter of this circular tank will be pi D. So the wear or flow rate, that is VW is equal to discharge passing through the circular tank, that is Q divided by perimeter of the circular tank, that is Q divided by pi D. Surface overflow rate. Surface overflow rate is defined as discharge passing through the circular tank divided by surface area of circular tank. Here the discharge passing through the circular tank is Q and diameter is T of circular tank. So it will be Q divided by pi D square by 4. Coagulation added sedimentation. Coagulation. Coagulation is the process of addition of coagulant in the water. There are three types of coagulant used in the water: alum, chlorinated copras, and copras. Flocculation. Flocculation is the process of combining of particles. Sedimentation. Sedimentation is the process of settling of the particle. Why we go for coagulation added sedimentation? Actually, in plain sedimentation, it will take 4 to 8 hours for the settlement of particle. But in coagulation added sedimentation, it will take 2 to 4 hours for the settlement of particle. That is, time is reduced approximately half. That's why we go for coagulation added sedimentation. The types of coagulants used are alum. The formula of alum is Al2SO4 whole thrice dot 18H2O. Al2SO4 whole thrice dot 18H2O.
20 S20.
Student, just wait. Sir will start very soon.
Am I audible to everyone? Hello.
Yes, sir. Well,
Okay, sir. Alum. The formula of alum is Al2SO4 whole thrice dot 18H2O. Al2SO4 whole thrice dot 18H2O. Copras. The formula of copras is FeSO4 dot 7H2O. The formula of copras, chlorinated copras, is FeCl3 and Fe2SO4 whole thrice.
Al2 into कौन सी फॉर्मूला होता है?
Hello. If you have any doubt, you can
एक
ask.
होता है सर, होता है
हाँ, बोलो.
Al2 whole 3
एलम का फॉर्मूला होता है Al2SO4 whole thrice. फिर से बोलो, तुम्हारा साउंड क्लियर नहीं आ रहा है.
Al2SO4 whole plus 24H2
डॉट 18H2O होता है,
ये सर
4H2 नहीं होता है. Alum works if pH of water is in the range of 6.5 to 8.5. Copras works if the pH of water is greater than 8.5. FeCl3. This works if pH of water is in the range of 3.5 to 6.5. Fe2SO4 whole thrice. It works if pH is greater than or equal to 8.5. Optimum dosage of coagulant. The dose or the coagulant added in water is calculated by jar test. This is jar test. In jar test, we have to take 6 beaker and add coagulant in different amount. Suppose in first beaker we have added 12 milligram of coagulant. In second, 14. In third, 16. In fourth, 18. In fifth, 20. In sixth, 22 milligram of coagulant. After that, rapid and fast mixing. We have to check the turbidity and plot a graph between turbidity and dosage. The dose corresponding to which turbidity is minimum is called optimum dosage of coagulant. The dose corresponding to which turbidity will be measured in NTU. Do you know what is the full form of NTU? NTU means nephelometric turbidity unit. It works on the basis of absorption principle or scattering principle. It works on the basis of scattering principle. Fast or rapid mixing. In raw water, first of all, we have to mix coagulant, and it is fast mixing, so that actually the particles, fine particles, cannot settle easily. Fine particles cannot settle easily in place sedimentation tank. That's why we are adding coagulant in the water, due to which actually fine particles do not combine with each other. Why? Because the nature of this, the charge on the particle is negative in nature. If those two particles come close to each other, then it repel. It do not combine with each other. So to combine the particles and increase the sizes, first of all, we have to add coagulant. Coagulant is positive in nature, which neutralize the charges on the surface of particle, suspended particle. That's why we are doing fast mixing, due to which all the coagulant which are positive in charge will be distributed uniformly in the sedimentation tank or in the flash mixer. After that, high speed, it is rotated with high speed. Why it is rotated with fast high speed? Because particles combine. After addition of coagulant, particle will combine. To increase the density of particle, as we know that settling velocity of particle is g by 18 g minus 1 d squared divided by nu. Settling velocity depends upon the specific gravity of particle. Here, the specific gravity of particle will be the flock, the specific gravity of flock. The specific gravity of flock will be more if the particle combine in condensed form or in compact form. So the particle compacted dense particle form if we increase the velocity of particle. After some time, it is rotated with the pedal is rotated with medium speed, because many particles combine with each other. If we rotate with high speed, then this flock will be disintegrated or break. After that, this blade or pedal is rotated with low speed, because in third case, the flock formed is very large. If we rotate with high speed, then it will disintegrate or break. So first rotate with high speed, after that medium, after that low speed. The flock finally formed will be dense in nature and large flock formed, which can settle easily. Our aim is to settle all the particles or maximum particles as soon as possible. That's why we are adding coagulant, so that most of the particles combine with each other and settle easily. Filtration. Filtration is the process of removal of suspended and colloidal particles from the water by passing it through porous medium. There are two types of filter generally used: solution filter and rapid sand filter. Solution filter. In solution filter, the sand particles used, the diameter of sand particle will be very less as compared to rapid sand filter. That's why the impurity are on the surface of sand. The impurity do not penetrate into the sand. Impurity are on the surface of sand only. Most of the impurity are on the surface of sand. In shallow sand filter, a submerged deck is formed. Do you know what is submerged deck? In the water, most of the particles are in organic nature. The microorganism decompose the organic matter, and this decomposed form a meat on the surface of sand. This is called a submerged deck. This submerged deck further helps in removing the suspended particle from the water. How to clean the filter? For cleaning of shallow sand filter, 1.5 to 3 centimeter of upper layer along with the submerged deck is removed. Cleaning is done if the head loss from the shallow sand is 0.7 filter bed. Rapid sand filter. In rapid sand filter, the diameter of sand used is large as compared to the shallow sand filter. Here, gravel is used. Gravel is used to support the sand and layer. This can be cleaned with the back washing. Rapid sand is 6,000 liter per meter square. Charge shallow sand is 100.
Okay, students, due to some network issues, they are actually facing some difficulties. So here basically the more objective of this today's observation is already defined by sir very good. That means we have idea that how we actually observe, we can actually the pollution rate and how we can control those things over for our environment, and some other way to solve this particular thing, that means not only from the theoretical concept, from other numerical aspects I have defined very well. So we are actually very motivated from this today's lecture, so that we can try to control our pollution, overall pollution. We cannot control, we can control our that means where we are actually from, that means our residential complex or our local environment pollution we can control, and that control will actually in a broader way, if we think, then it will be control in the worldwide. Okay, so from today's lecture we are that means we want to thank you, Niranjan sir, for your brief lecture. We know that in our college there are some difficulties for network issue is going on, so definitely we will try to arrange some another attractive session from your side some another day, maybe in some when college will open, then we'll try to organize one physical class for all those students who are actually right here now. So thank you all the students for joining with us, and follow our Instagram and Facebook page for the next program, and hopefully you will like all those programs we are actually doing for your for innovation and for from the ISSL actually to develop our innovative ideas and to encourage students for the innovation and entrepreneurship issue. So college definitely will open after the holy vacation. Definitely physical class will start, then we will do practically, or we will meet again in the college physically. We will attend this type of workshop and seminar in future. And social media link already I have shared. Right now I don't have any information, so you just search IIC Chaibasha in Facebook as well as in Instagram. You will find our college Instagram and Facebook page. Thank you all. We are closing this session. Thank you, Niranjan sir, for such a attractive lecture. Thank you all.